2.4. Oh, your wrist hurts. You didn't do your homework last night. So today is called deductive reasoning. And remember, I promised yesterday that if we made it through 2.4, your writing would decrease drastically. So here's the day. We're going to make it through 2.4. Will decrease drastically after today. What? Oh, no, I think that's the truth. Well, 2.5 has a lot less writing. Well, okay. All right, today we get to be lawyers in a way because we're going to talk about two laws. And so we're going to discuss two laws in geometry. And if you know anything about lawyers, the details are going to be important for us today. And we have to make sure we're following the letter of the law as we go through these. So this is 2.4, deductive reasoning. And I'm going to go ahead and uncover our definition. So deductive reasoning is using facts, rules, definitions, or reach logical conclusions. And once you have that down, don't worry about writing the other stuff because we're going to make sure we understand what deductive reasoning is before we move on to the first law. As you're writing that, also think about the other type of reasoning we learned in section 2.1. It was called inductive reasoning. So there are two types of reasoning in geometry, inductive and deductive. This is now the second type. If you remember inductive reasoning, it was when I said something like 1, 3, 5, 7, and you said 9. So inductive reasoning was kind of coming up with a next answer after you see a lot of examples. So for inductive reasoning, you didn't necessarily know what the pattern was going to be. You had to figure that out. Deductive reasoning is where you know the pattern and you have to follow that. So here's where you see deductive reasoning a lot. In any type of board game, when you play a board game, unless your family cheats a lot, you follow the rules. So you get out that little rule book. Aiden, does your family cheat?
My brother, we were playing a game called Headbands during Christmas time, and he kept looking into the ornaments on the Christmas tree to see what his character was.
So he was not following the rules. He had bad deductive reasoning. I know, that's true. So deductive reasoning is when you have a set of rules and you follow them. You follow them to a T. So your student handbooks or schools in general have a lot of deductive reasoning. Like on the bad end, our student handbooks say if you're tardy 3 days, you get a detention. So that's following rules. So let's say, this isn't going to happen because you guys are always on time, but let's say Noah was late to school Monday. Noah was late to school Tuesday. Noah was late to school Wednesday. On Thursday, Mr. Ashbrook gave him a detention. Mr. Ashbrook was following deductive reasoning because he was following the rules. And so you look at the rules, you tell what happens next. Whereas inductive reasoning, you just look at a bunch of examples. You don't necessarily know what the rule is. You got to have to figure it out to guess what's going to happen next. So deductive reasoning, I think the best thing is to think of games and know that Aiden's brother does not follow deductive reasoning. That's what you can remember. But inductive reasoning is figuring out what's going to happen just based on what you have to look at from past examples. So that's your difference. All right, so now we're going to talk about the first law, and this is the law of detachment. So go ahead and copy down what you see in blue. You just wanted to get on camera. What? You just wanted to get on camera. So you've got a couple things here. We have some symbols in there. We have some letters for statements. So we're going to look at this in pieces, and then we'll look at an example. Remember, C, P, arrow, this, it's a conditional. So this is saying if you have a conditional that's true, and the first part of it is true, if the hypothesis is true. So you have an if-then statement, and the if part is true. This law says the conclusion has to be true. Or they're going to pop in this word valid now. Valid means true. So think about that. They're saying you have an if-then statement, and the first part is a T. For that overall to be true, doesn't the second part have to be a T? Because are you allowed to have a TF combo for it to overall be true? No. So this is what the law is, and we're going to look and see how I can ask you questions on that. And we're going to start with one that makes sense in our heads. We're going to start with a grade question that should make sense. So for example 1, copy down this conditional and copy down this given statement. The conditional is an if-then statement, and that conditional says if you get 100% on your test, then you get an A. And we're going to say Lisa got 100%. Now, here's my question here. Is that conditional true? Would you say that if you get 100%, you get an A? Yeah, that's true. We all know that. Mad at me. So if you get 100%, then you get an A. Okay, Lisa, you all know Lisa. She sits right behind Devin. Lisa got 100%. What does Lisa expect to happen? Lisa got an A. Doesn't that just make sense? Laws are supposed to make sense most of the time. But this is logical. You have a true conditional. The first part has been proven, so the second part has to be true. Now here's the thing. Order is important. When you have the law of detachment, in all kinds of laws, order is important. When you have the law of detachment, you first have to have a conditional, then you have to have something, the if part, and then you have something that confirms the then part. It has to be in that order. Conditional, then the if part becomes true, and then lastly the then part becomes true. Now here's something else I want to point out. For the given, if you remember I said something about the given last week, or maybe it was this week. The given is always true. Don't mess with the given. So if there's any information that says given, you can't mess with it. That has to be true. So this is how we're going to work through our law of detachment. Now that was an easy example because that was to show you how the law works. Now we're going to beef it up a little bit with a geometry example. Second example. Copy down what you see in blue, and then we're going to work through the law of detachment with this. It's kind of wordy, I know, but we're lawyers today. It's all about the words. Shake it off. Okay, so the first thing we have to do for a law of detachment is we have to see if we have a true conditional. Okay, so this part that you just wrote, is that a conditional? Does it have an if-then part to it? Yes, it does. It's a conditional. Now we have to figure out if it's true. So we're going to look at this if part first. So for this if part, I know it's very wordy, but I'm going to use these symbols to help. It says if two segments are congruent. So I'm going to represent that as A, B, B, C. Those are congruent. If two segments are congruent and the second segment, so two segments are congruent, that second one is congruent to another one, then the first segment is segment. Does that make sense? If this is 5 long and this is 5 long, well, BC is 5 longs, CD is 5 long. Shouldn't these two 5s be equal? Yeah, that makes sense. So this is true. This is a true. That's the first part of the law of detachment. Do you have a true conditional? Okay, now we're going to look at some other parts of the law of detachment. So for this part, go ahead and write down this given and conclusion. Okay, this is a specific example of that conditional, and we're going to see if it matches up. Okay, remember what I said about the given? Don't mess with the given, it's always true. So this piece, this line right here has to be true. Wx equals uv and uv equals RT. So the next thing that happens in the law is that the if part has to be confirmed. Okay, so here's the if part. Is that what we have in the given? Do we have two segments that are congruent and the second segment is congruent to a third. Is that confirmed? Okay, then the last part of the law of detachment has to confirm the then part. Does the conclusion confirm the then part? Then the first segment is equal to the third segment. Yeah. So does it have all three parts? A true conditional, a confirmation on the if, and a confirmation on the then? It does. So we're going to call this a valid law of detachment. Valid makes it sound fancy. Yes, Logan. Yes. Just carry it with you. Okay, now I'm going to do a little twist. I'm going to, instead of doing a whole new conditional and making you write that all out again, we're going to keep that conditional, but change our given and conclusion. So this is like a part 2, but using the same conditional so we don't have to write it all out again. Okay, so the conclusion, we're using the same conditional we had way at the beginning. So for law of detachment, you have to have a true conditional. We have that. Then next, you have to confirm the if part. Does that given confirm the if part? If two segments are equal and the second is equal to a third? No. As soon as you get something that doesn't work, you stop. Does anybody know, anybody like really catching on and you know what they did between the given and the conclusion? Didn't they switch it? They put the if part there and the then part here. But is order important? You better believe it. For a law, it has to go in order. You have to have a conditional, then you have to confirm the if part, and then you confirm the then part. And they didn't do that. They flip-flopped the order. So this is invalid. All right, now, I know this is kind of boring. I understand. So that's law of detachment, and we're just going to leave it there for right now. We're going to move to the next law. We'll practice this again. But this next law is out of the two. So we're going to spend some time with this. And it is called the law of syllogism. So I'm going to have you copy down the name and then this line, and we're going to watch something in just a second. And so copy down this. This is our law, and I'll explain it in just a second. We do. Yeah, go ahead and just write all those because we're going to need them anyways. This is the last part you'll have to write if that gives you any consolation. None of your other classes will make you write today. There you go. Free pass. If you're talking, you better be writing. Right. Okay. Then you get 2 days to rest, and then you can come back Monday ready to go again. Keep writing. Yeah. Keep writing. Less mouth moving, keep writing. Write it all except the watch this. Keep writing. We got to know what the law is, but you need to write it first. It's on progress book. Okay, let's kind of talk about this. First of all, let's look at the law itself. In the law itself, there are 3 important parts, and I'm circling those right now. All 3 of those parts are conditionals. So when you do the law of syllogism, you're going to end up with 3 if-then statements. Okay, now pay attention up here. I need your attention, please. Thank you. So, for law of syllogism, 3 if-thens. Okay, now here's the next thing. Follow my fingers up here as we look. This first conditional, P, Q. The second conditional, Q, R. And then P, R. The order of those letters is important. The first 2 conditionals have to look like this. See how the one ends like the second one begins? That has to happen or it's not a law of syllogism. And then, if the first one ends like the second one begins, the third one is a combination of the ends. Do you see how that works?
Pardon this interruption. Career Center students, throughout the day, before you go to the Career Center, please check into the main office first. Career Center students, check into the office first. Thank you.
Okay, so the first one ends like the second one begins, and then you join the P for the last conditional. Okay, so we have our 3 statements. You are in geometry, you go to school, you have homework. So the first conditional that I wrote was P arrow Q. If you are in geometry, then you go to school. The second one I wrote was Q arrow R. If you go to school, then you have homework. The third conditional is P arrow R. If you are in geometry, then you have homework. So what you're going to have for questions, you're going to have these first 2 conditionals. You're going to have to come up with the third. Now here's what I think in my head. I think of canceling things out. It's probably not something you'll find in a textbook, but for the first and second conditional, if the first one ends like the second one begins, they cancel each other out. What's left? Your answer. So that's how you can do law of syllogism. The first one ends like the second one begins, cancel those out, so your final if-then statement, if you are in geometry, then you have homework. That's a good conditional. I like that. If you are in geometry, then you have homework. I really like that. Okay, here's my question. What if this one ends differently than this one begins? Then it's invalid. I like it. Great. It has to do that. All right, now we're going to end real quickly with a couple videos. I was watching TV a couple summers ago, and there was this commercial that had the law of syllogism. Can you believe it? A commercial had the law of syllogism. So I'm going to show you that commercial, and I'm going to see if you can figure out why.